Very good morning, students. In the last class, we are completing stoichiometric calculations theory part. Now we are discussing competitive questions based on the stoichiometric calculations. Here, objective questions from some basics of chemistry, expected questions from stoichiometric calculations only. More concentrate until completion of video. You are not diverted. Each sum is very important. Clear, students? Once again I will repeat, from some basics of chemistry, expected question from this topic only, that is stoichiometric calculations. First question, student. For the reaction x plus 2y gives z, x plus 2y react with one another to give rise to z, one general chemical reaction. For the reaction x plus 2y gives rise to z. If 5 moles of x react with 9 moles of y, if 5 moles of x react with 9 moles of y, how many moles of z is formed? First option, 5 moles of z, 8 moles of z, 14 moles of z and 4.5 moles of z. For this chemical reaction, 5 moles of x react with 9 moles of y, how many moles of z is formed? By using stoichiometric calculation. It is given information, student. Come to the solution. We know that the given reaction is x plus 2y gives rise to z. X plus 2y gives rise to z. From this stoichiometric equation, 1 mole of x react with 2 moles of y to form 1 mole of z. 1 mole of x react with 2 moles of y to form 1 mole of z. We know that the coefficient present before the reactants and the products are known as stoichiometric coefficient, which is known as number of moles. Nothing is there means here 1 is present. 1 mole of x react with 2 moles of y to form 1 mole of z. Here nothing is there means nothing is not there means 1 is present. The number of moles of x are 1. The number of moles of y is 2. The number of moles of z is 1. Therefore, 1 mole of x react with 2 moles of y to form 1 mole of z. Here, the number of moles of x and y are present in the 1:2 ratio, 1:2 stoichiometric ratio. For every 1 mole, 2 moles of y is required. If x is 1 mole, y is 2 mole. X is 2 moles, y is 4 moles. X is 3 moles, y is 6 moles. X is 4 moles, y is 8 moles. X is 5 moles, y is 10 moles. According to stoichiometric equation, for every 1 mole of x, 2 moles of y will be required. For every 5 moles of x, 10 moles of y is required. But in our question, they are given if 5 moles of x react with 9 moles of y, how many moles of z is formed? We know the students, according to stoichiometric ratio, if they are present in 1:2 ratio, the number of moles can be determined very easily. 1 mole of x, 2 moles of y, 1 mole of z is formed. 2 moles of x, 4 moles of y, 2 moles of z is formed. 3 moles of x, 6 moles of y, again 3 moles of z is formed. If they are present in 1:2 ratio, the number of moles of x is equal to the number of moles of z. No problem. But here, in the given question, they are given 5 moles of x react with 9 moles of y. How many moles of z is formed? Here we are using the concept of limiting reactant and excess reactant. Just I recall the topic once again, student. Limiting reactant. The reactant which is present lesser than the required amount and completely consumed in a chemical reaction are known as limiting reactant. The reactant which is present less than required amount in a chemical reaction and completely consumed are known as the limiting reactant. Here, student, for 5 moles of x, we can require 10 moles of y because the stoichiometric ratio is 1:2. But in the question, they are given 9 moles only. Therefore, the reactant y is having less than required amount. Required amount is 10 moles of y for y moles of x. In the given question, they are given 9 moles of y. Therefore, the reactant which is present less than required amount. Required amount is how much, student? Here 10 moles of Y is required. 10 moles of Y is required. But they are given 9 moles only. That is, the reactant which is present less than required amount, in a chemical reaction are known as limiting reactant. Hence, therefore, otherwise is excess reactant. Other one is the excess reactant. Here, Y is the limiting reactant, X is the excess reactant. We know, the students, the product formation always takes place based on the limiting reactant only. The amount of the product formation takes place depends on the limiting reactant only. Why? Because the limiting reactant is completely consumed. Until the completion of the limiting reactant only, the product is formed. For example, student, if the 9 moles of X, 9 moles of Y is present, that is completed. Once the reactant Y is completed, then there is no reaction between X and Y. Why? Because Y is completely consumed. Hence, there is no product formation of Z. That is, until how much time the reactant Y is present, that much amount of product is formed. Once the reactant Y is completed, the product formation does not take place because the Y is not possible, Y is not present to react with the X, to react with the reactant X. Therefore, students, here 9 moles of Y is the limiting reactant. 9 moles of Y is the limiting reactant. 5 moles of X is the excess reactant. It is completely consumed. It is not completely consumed. Why? Because for 2 moles of X, 1 moles of Y is required. For 2 moles of Y, 1 mole of X is required. For 9 moles of Y, you can require exactly half. 4 moles of 4.5 moles of X is required. 4.5 moles of X is required. Given 5 moles, 4.5 moles is consumed and 9 moles of Y is completely consumed. Hence, it is clear that it is the excess reagent. Among the reactants X and Y, 5 moles of X is present. In that 4.5 moles of X is consumed. Remaining is 0.5 moles. That is excess reactant. Here 9 moles of Y is present. That is completely consumed. Therefore, basing on the limiting reactant only product formation takes place. Hence, for 2 moles of Y, 1 mole of Z is formed. According to stoichiometric equation, for 2 moles of Y, 1 mole of Z is formed. Then for 9 moles of Y, how many moles of Z is formed? 9 moles of Y, how many moles of Z is formed? Cross multiplication, 9 into 1 by 2, that is equal to 4.5 moles. That is equal to 4.5 moles of Z is formed. How many moles formed, student? Here 4.5 moles of Z is formed. 4.5 moles of Z is formed. Okay, students, and simply also we will discuss that is simple method. Given ratio is 1 mole of X plus 2 moles of Y gives 1 mole of Z. 1 mole of X react with 2 moles of Y to form 1 mole of Z. Here the reactants X and Y are present in 1:2 ratio. For every 1 mole of X, 2 moles of Y is required. For every 5 moles of X, 10 moles of X is required. But in the question they are given 9 moles. The reactant which is present in lesser amount, therefore it is the limiting reactant. Always the product formation depends on the amount of the limiting reactant but not excess reactant. Hence 2 moles of Y is equal to 1 mole of Z, 9 moles of Y is equal to how many moles of Z? Cross multiplication, 9 into 1 by 2, that is equal to 4.5 moles of Z. 4.5 moles of Z. In any chemical reaction, the amount of the product formation purely depends upon the amount of the limiting reactant only. Because the limiting reactant is completely consumed. Once the limiting reactant is completed, there is no reaction between that reactant and other reactant. Hence, the correct answer is 4.5 moles of Z. Therefore, D is the correct answer. Copy this, students. Next continuation, student. Question number 2. Manganese dioxide react with HCl gives manganese dichloride plus water plus chlorine. In the given chemical reaction, 1 mole of manganese dioxide react with 4 moles of HCl to form 1 mole of manganese dichloride and 2 moles of water and 1 mole of chlorine. But in the given chemical reaction, they are given if 2 moles of manganese dioxide react with 4 moles of HCl to form 11.2 liters of chlorine at STP. 11.2 liters of chlorine at STP. Once again student, if 2 moles of manganese dioxide react with 4 moles of HCl to form 11.2 liters of chlorine gas at STP. What they are asking, thus the percent yield of chlorine is, the percent yield of chlorine. How much percentage of chlorine is present for this reaction? How much percent yield of chlorine is present? Dear student, according to the given chemical reaction, MnO2 plus 4HCl gives MnCl2 plus 2 moles of water plus chlorine. 1 mole of manganese dioxide react with 4 moles of HCl to form 1 mole of chlorine. We know that at STP condition they are mentioned 1 mole of any gas at STP occupies a volume of 22.4 liter. Therefore, if 1 mole of HCl, 1 mole of manganese dioxide react with 4 moles of HCl to form 22.4 liters of chlorine. According to stoichiometric equation, the amount of the volume of chlorine liberated is how much today? 22.4 liters. But according to the given question, 2 moles of manganese dioxide react with 4 moles of HCl. How many liters of chlorine is liberated, student? 11.2 liters of chlorine will be liberated. That is, if 2 moles of HCl react with 2 moles of manganese dioxide react with 4 moles of HCl to form 11.2 liters of chlorine. According to stoichiometric equation, 22.4. According to given question, 11.2. Therefore, the percent yield is given volume by actual volume into 100% yield. For suppose I got 35 marks, how much percentage means 35 by 100 into 100. I got 75 marks, 75 by 100 into 100. Obtained marks by total marks into 100. Here also obtained volume by total volume into 100. According to given question, the volume is 11.2. That is actual volume obtained for the given stoichiometric equation is 22.4 into 100. 11.2 divided by 22.4 into 100. That is 1 by 2 into 100. That is equal to 50%. Percent yield, 50% is the percent yield of chlorine. Very simple, student. Without doing any calculation also, we will do this. Okay. Here according to stoichiometric equation, 22.4 liters of the chlorine is obtained. It is 100% of the volume. Here according to given question, 11.2 liters is obtained. In 22.2 liters, 11 point is half, that is 50%. That is 50% of chlorine is the percent yield of the chlorine. 50% is the percent yield of the chlorine. Given students, like these questions are given, the formula is percent yield is equal to given volume by actual volume into 100. Given volume is 11.2 liters. According to question, they will give how much volume they are given. Next one, actual volume is according to stoichiometric equation. How many moles is present? If 1 mole is present, 22.4. 2 moles is present, you can take 44.8 liters. Therefore, percent yield is equal to 50%. Percent yield is 50%. B is the correct answer. Next question, student. Question number 3. Very easy question. Which of the following equation is unbalanced? First one is 4Fe plus 3O2 gives 2Fe2O3. 2 moles of magnesium plus oxygen gives rise to 2 MgO. P4 plus O2 gives P4O10. CH4 plus 2O2 gives rise to CO2 plus 2H2O. It is trial and error, student. Here this equation is given. C option, that is not balanced because P4, 4 phosphorus atoms are present and oxygens are 2. Here oxygens are 10. The number of oxygen atoms on the reactant and the product side are not equal. Therefore, the reaction is not balanced. To balance this, if you take 5 moles of oxygen, the reaction is balanced. P4 plus 5O2 gives rise to P4O10. Hence, it is clear that the C option is the unbalanced equation. P4 plus O2 gives rise to P4O10. Therefore, C is the correct option. Next one, student. Question number 4. CH4 plus 2O2 gives rise to CO2 plus 2H2O. According to the above chemical reaction, following information has been given. Okay, here 1 molecule of methane can react with 2 molecules of oxygen to form 1 molecule of carbon dioxide and 2 molecules of water. We know the student, 1 molecule can take, then here also 2 molecules, here also 1 molecule, here also 2 molecules. If you take number of moles, 1 mole of methane react with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. Similarly, student, 1 mole of methane, how much volume, student? 22.4 liters. 22.4 liters of methane react with 44.8 liters of oxygen to form 22.4 liters of carbon dioxide and 44.8 liters of the water gas, 44.8 liters of the water molecule. Clear, students? In terms of masses, number of moles as well as the volume also they are given 4 options. First one, they are given 1 mole of methane react with 2 moles of oxygen to give 1 mole of oxygen, 1 mole of carbon dioxide and 2 moles of water. Correct statement, student. That is, next one is 1 molecule of methane react with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of water. Correct, that statement is also correct. Next one, 22.4 liters of methane react with 45.4 liters of oxygen to give 22.7 liters of carbon dioxide and 45.4 liters of water. According to number of moles, that statement is also correct. Okay, in terms of molecules, in terms of moles, in terms of volume they are explained. Next one, in terms of mass also they are explained, student. The molar mass, 1 mole is, the molar mass of methane is here 14, carbon is 12 and plus 4, 12 plus 4 16, 12 plus 4 16 grams of methane. The mass of 1 mole of the substance which is expressed in grams are known as molar mass. The molar mass of methane is 16 grams and the molar mass of oxygen is how much grams here, student? Oxygen is 16, oxygen molecule 32, here 2 moles are there, 2 into 32, that is equal to 64 grams, that is equal to 64 grams. Similarly, carbon dioxide, carbon is 12, oxygen is 32, 12 plus 32, that is equal to 44 grams, that is equal to 44 grams. And 2 moles of water molecule. Number of moles of water molecules are 2 moles and oxygen is 16, hydrogen is 2, 16 plus 2 that is 18, that is 36 grams, that is equal to 36 grams of water molecule. Then check the fourth point, student. 16 grams of methane react with 2 into 32 grams of oxygen to form 44 grams of carbon dioxide and 36 grams of water. All these statements are given, students, in terms of molecules, in terms of moles, in terms of volume, in terms of molar mass they are given. But what they are asking, from this information, the true interconversion is, here students, B is the correct one. That is, moles can be changed to mass can be converted into molecules, We know that, students, molecules can be converted into moles can be converted into molar mass. And molar mass can be converted into volume also, That is not given, student, here, no problem. Clear, students? The correct answer is B is the correct answer. Masses, equilibrium, moles, equilibrium, number of moles. These three are interconvertible. If moles are given, we have to calculate mass. If mass is given, we can calculate the molecules. If molecules is given, mass calculate. Mass is given, moles is also calculate. B is the correct option. Clear, students? Next one. Question number 5. How many number of molecules and atoms respectively present in 2.8 liters of diatomic gas at STP? How many number of atoms and molecules are present in 2.8 liters of diatomic gas? Diatomic gas is here. Let us consider A2, student. A2 is the diatomic gas. The gas which is having 2 atoms are known as diatomic gas. Examples are H2, Cl2, Br2, like this. The volume is equal to 2.8 liters. The diatomic gas can occupy a volume 2.8 liters. Then how many molecules and atoms are present? There are senses, student. One diatomic gas A2 which can occupy a volume 2.8 liters. The diatomic gas A2 can occupy a volume 2.8 liters. Then they are asking how many diatomic molecules are present, how many atoms are present, Therefore, student, by using the volume, we have to find out number of moles. From the number of moles, we can calculate number of molecules. From the number of molecules, we can calculate number of atoms. Clear, students? Here volume is given. From that, we can calculate moles from that, molecules from that atoms we are calculating. Therefore, volume is equal to 2.8 liters at STP, standard temperature pressure. The volume of the given gas is 2.8 liters at STP. Therefore, number of moles is equal to volume of the gas at STP by 22.4 liters. Volume of the gas at STP by 22.4 liters. This is how much, students? 2.8. 2.8 divided by 22.4, that is equal to 0.125 moles. 0.125 moles. Number of moles is calculated. Next, number of molecules is equal to number of moles into Avogadro number. Number of moles into Avogadro number. 0.125 into 6.022 into 10 to the power of 23, that is equal to 7.5 into 10 to the power of 22 molecules are present. Therefore, 2.8 liters of a diatomic gas A2 contains how many molecules, student? 7.5 into 10 to the power of 22 molecules are present. 10 to the power of 22 molecules are present. We know that each molecule contains 2 atoms. Why? Because diatomic means 2 atoms. 1 molecule, 2 atoms. 2 molecules, 4 atoms. Here, this much number of molecules are present. 7.5 into 10 to the power of 22. The number of atoms is 7.5 into 10 to the power of 22 into 2. That is 7.5 into 10 to the power of 22 into 2. We know that 7.5 into 2, that is equal to 15. 15 into 10 to the power of 22 atoms are present. 15 into 10 to the power of 22 atoms are present. Therefore, 2.8 liters of the diatomic gas contains 7.5 into 10 to the power of 22 molecules. 15 into 10 to the power of 22 atoms. 10 to the power of 22 atoms. Hence, the correct option is question number 5. C is the correct option. C is the correct option. Here, very simple thing, student. Volume is given, converted to moles, which is converted to molecules, which is converted to number of atoms. Copy this, students. Okay, next continuation, students. Question number 6, similar model to the last questions, that is 15 and 16 at the time we are discussing. Next one is question number 7. In the reaction, 2 moles of aluminium react with 6 moles of HCl to give 2 moles of Al plus 3, 6 moles of Cl minus ion and 3 moles of hydrogen and 3 moles of hydrogen. Here 4 options are given. Which option is correct we have to identify. Which option is correct we have to identify. 2 moles of aluminium react with 6 moles of HCl to form 2 moles of Al plus 3, 6 moles of Cl minus and 3 moles of hydrogen. Here first option, student, 6 liters of HCl consumed for every 3 liters of hydrogen. 6 liters of HCl consumed for every 3 liters of hydrogen. Here, student, for suppose 6 into 22.4 liters of HCl is equal to 3 into 22.4 liters of hydrogen. For every 6 into 22.4, here 3 into 22.4. Here these HCl and hydrogen are present 6:3 ratio. But that is at which condition, student? STP conditions only. STP conditions only. By seeing this statement, you can think it is correct only. That is 6 liters of HCl is consumed for every 3 liters of hydrogen is produced. That is, to produce 3 liters of hydrogen, 6 liters of hydrogen is consumed. Similarly, here 6 into 22.4 liters of HCl is consumed, 3 into 22.4 liters of the hydrogen is produced. This is at what condition, student? STP conditions only. Yet standard temperature pressure, 1 mole of any gas can occupy a volume of 22.4 liters. But here 6 into 22.4 liters of HCl is consumed. 3 into 22.4 liters of hydrogen is obtained. Similarly, 6 liters of hydrogen is consumed, 3 liters of hydrogen is obtained. But at STP conditions only. If STP conditions they are mentioned, the first statement is correct, then it is not correct. Why? Because here 6 liters of HCl is consumed for every 3 liters of HCl is produced. That is wrong statement because they are not mentioned standard temperature and pressure. Standard temperature and pressure. Why? Because, students, 1 mole of any gas can occupy a volume of 22.4 liters at STP. Second statement, student, 33.6 liters of hydrogen is produced regardless temperature, pressure for every mole of aluminium that reacts. For every mole of aluminium that reacts. 33 liters of HCl is produced 33 liters of HCl will be produced. That is the wrong statement, student. Why? Because here 3 into 22.4 liters, that is equal to 67.2 liters. That is equal to 67.2 liters. 67.2 liters of the hydrogen is obtained by consuming 2 moles of aluminium. Then for one aluminium, how much, student? Nearly that is 33.6. 33.6. Once again, student, for 2 moles of aluminium, 3 moles of hydrogen is obtained. 3 moles of hydrogen is obtained. Similarly, the 3 moles of hydrogen is equal to 67.2 liters. 67.2 liters of hydrogen. Therefore, 2 moles of hydrogen can liberate 67.2 liters of hydrogen. 2 moles. Then for 1 mole, how much, students? That is in this half. That is 33.6 liters. 33.6 liters. That is appears as the correct statement, but that is also not correct. Why? Because here they are mentioned one thing: produce regardless of temperature and pressure. Regardless of temperature and pressure for every mole of aluminum that reacts. Regardless means irrespective of temperature and pressure. Irrespective of temperature and pressure means they are not mentioned again STP condition. If they are mentioned STP condition, for every mole of HCl, every mole of aluminium, 3 moles of hydrogen is obtained. That is 22.4 into 3, that is 67.4. 2 moles 67.2 liters, 1 mole 67.2, that is equal to 33.6 liters of hydrogen is obtained. Here remember, student, if they are mentioned STP conditions only, that volume statements are correct, otherwise it is not correct. Next, third statement, student, 67.2 liters of hydrogen at STP is produced for every mole of aluminum that reacts. Here they are mentioned STP condition. 67.2 liters of hydrogen is obtained at STP for every mole of aluminum that reacts. Every mole means they are given for 1 mole of aluminum that reacts. But 67.2 liters is obtained from 2 moles. 2 moles of aluminium can use 67.2 liters of hydrogen. But what they are given, student, 67.2 liters of hydrogen is obtained for every mole of aluminum that reacts. That is for every 1 mole of aluminum that reacts. That statement is also wrong statement, because 67.2 liters is obtained from 2 moles of aluminium but not from 1 mole of aluminium. Last statement, student, 11.2 liters of hydrogen at STP is produced for every mole of HCl. For every mole of HCl. Yes, student, here every mole of HCl means 1 mole of HCl. That is 6 mole of HCl can give 3 moles of hydrogen. 6 into 22.4 liters of HCl can give 3 into 22.4 liters. Clear, student? If 6 into 22.4 means 3 into 22.4. I will give calculation, student. That is 6 moles of HCl. 6 moles of HCl. How much volume, student? Here 67.2 liters of hydrogen. Clear, student? For 6 moles, 67.2 liters. But what they are, student? For every mole of HCl, for every mole of HCl means for 1 mole of HCl, for 1 mole of HCl, how many liters of hydrogen is obtained? How many liters, student? Cross multiplication. 1 into 67.2 divided by 6, that is 67.2 divided by 6, that is nearly 11.2 liters of hydrogen will be obtained. The last statement is correct, student. The last statement is the correct one. 11.2 liters of hydrogen at STP is produced for every mole of HCl that is consumed. That is 1 mole of HCl react with aluminium to form 11.2 liters of hydrogen. 11.2 liters of hydrogen. See, students, these 4 statements appears as the correct statements, but only one is correct. Why? Because at STP conditions they are mentioned. At STP conditions you have to check as well as the correct molar ratio. Correct molar ratio. Correct molar ratio. 2 moles of aluminium react 6 moles of HCl to form 2 moles of Al plus 3, 6 moles of Cl minus, and 3 moles of hydrogen. 3 moles of hydrogen. Therefore, the correct answer is D is the correct answer. D is the correct answer. Clear, students? Next one. 2.76 grams of silver carbonate on being strongly heated yield a residue of weighing. Here 2.76 grams of silver carbonate is heated. What is the weight of the residue is formed? Residue means remaining substance. Residue means remaining substance. Like this you can solve, student. When silver carbonate is heated, it it can form silver plus carbon dioxide plus oxygen. Silver plus carbon dioxide plus oxygen. 1 mole of the silver carbonate, 1 mole of the silver carbonate is heated to form 2 moles of silver, 1 mole of carbon dioxide and half mole of oxygen. This carbon dioxide and oxygen are the gases that can enter into atmosphere. Clear students? They are not remaining in the reaction mixture. Let us consider test tube. The test tube contains silver carbonate. If the silver carbonate is heated, then carbon dioxide enter into atmosphere. Oxygen is enter into atmosphere. Silver is not enter into atmosphere because that is solid. The solid will be remaining at the bottom of the test tube. That is known as residue. Residue means remaining substance. When 1 mole of silver carbonate is heated, 2 moles of silver is formed as a residue. Remaining carbon dioxide and water enter into atmosphere. Now we have to find out the weight of the silver. For example, student, 1 mole of silver carbonate upon heating gives 2 moles of silver as the residue. 1 mole of silver carbonate has the molar mass 276 grams. Because the mass of 1 mole of the various atoms present in the one molecule are known as molar mass. Silver is 108. 2 into 108 plus carbon is 12 and oxygen is 16. 3 into 16. The total is how much, student, here? 276 grams. The mass of silver carbonate is 276 grams. This is upon heating. 2 into 108 grams. 2 into 108 grams of the silver will be obtained. The atomic mass of silver is 108 grams. Because of 2 moles, 2 into 108 grams. Therefore, 276 grams of silver carbonate upon heating, 216 grams of silver will be obtained. Silver will be formed as the residue. But in the given question, what they are going, student? If 2.76 grams of silver carbonate is heated, what is the weight of the residue is formed? What is the weight, student, here? 276, 216, silver is the residue. 2.76, how much amount of silver formed as the residue? Simply, student, cross multiplication. That is 2.76 into 216 divided by 276. That is 0.01 into 216, that is 2.16 grams of the silver. 2.76 grams of silver carbonate is heated, 2.16 silver is formed as the residue. Therefore, the correct answer is A is correct answer. Copy this, students.